I believe this is spiral 8, so let's just get to this. Can I write on this? No, I can't. Can I write on this? Yeah, I can. Alright, so spiral. Remember what the purpose of spiral is. So to get you, what do you call, up to date so that you don't forget these topics that you learned earlier on in the year by the time the state test comes. So, again, they're very straightforward right now. I will be changing the questions at some point to more word problems. 42 and 28, GCF. 7 goes in 42 6 times, 4 times. Well, look at that, I can continue. 2 goes into 6 3 times, goes to 4 2 times. So I'm done. Nothing can go into 3 and 2 except 1, so I know I'm done. So the GCF is a product of those two numbers. And 7 times 14. 7 times 2 is 14. That's my GCF. LCM of 36 and 48. Yikes, that's going to be a big number. 12 goes into both, so we can go 3 over here and 4. I can't continue, so LCM is a little bit different. We multiply the numbers on the side and at the bottom. So 12 times 3 times 4. So the LCM is the product of those numbers, and that's going to be 144. Because 3 times 4 is 12, and I multiply by 12, it gives me 144. Okay. I do want to say work for this one. I won't give you credit if there's nothing shown here. Division problem. Okay, so he has 3 and 1/4 container. And we want to put that in 1/5 gallons. So how many 1/5 gallons can we get out of this? 1/5. Life is easier if you, for me at least, if you change that to a mixed number, improper. So 4 times 3 is 12 plus 1. So I'm going to write 13 over 4 divided by 1/5. So that's my problem. You can multiply by the reciprocal. I still will ask you to, you can do it, but I like the idea that you know that if you do it this way, you know exactly why your answer is what it is. So the LCM is 20. So this is going to be a 4, and 5 times 3 is 65, right? We can cross these out because they're dividing same units, so it becomes 65 over 4. And 65 goes into 4, or 4 goes to 65, 1, 4, 25, 16 times. So we can make 16 1/5 containers, and 24, and it's going to have 1/4 left, and 1/4 of the next bottle. So definitely this much left over, and this much left over, but 16 full 1/5 containers. So imagine if you had a bunch of 3, make this another picture, 3 full gallons of milk and 1/4 of the next one. So about this is how much you have of milk, and you're trying to put it into containers that are gallon size, but how many of these can I make? I can make 1, fill another container, I can put 1/5 in here too, so you can make 16 of these, okay? And the last one, you can fill 1/4 of it. Imagine you can put like 1/4 of what you're trying to do. Okay. How much would it cost to buy 20 stamps? So unit rate problem. 18.72. I get 12 bucks. My unit rate for one book. So 18.72 for 12 bucks. It's not a bad price at all. It's going to give me $1.56 per book. So these are probably comic books or something. $1.56. Now I can use my unit rate to find out how many. Oh, these are stamps. Okay, so one says stamps, one says book. So let's just change this to stamps. Now let's keep it at books and change this to stamps are 40 something cents. So 20 stamps or books, so 20 books, how much would it cost? That's easy now because I have my unit rate times 20, and if I multiply 1.56 times 20, I get the 31 $31.20, $31.20, $31.20. Okay, and I need to charge. So give me a second. Charging. We're done with these two. Let's go. What again? So I'll solve this a little bit differently. We can subtract to find what value of x, add it to 9.7604. It gives me 87.67765. A lot of people do it this way, or you will be doing it somewhat like this, where you do this. You subtract 9.760604 from this side and minus 9.7604 on this side. These two become 0, so there's no need to write it. So x comes down, and you're going to find that it's the same thing. So 87.765 minus 9.7604, that gives you 78.0046. Okay, so 65 minus, if you were to line up the decimals correctly, like this, and you add a placeholder, and you would subtract, and that's what you would get. Okay. Which is exactly what we just did over here. Okay. But the idea here is that to think of an equation as something that's balanced, where the left side equals the right side. So if you subtract a value from the left side, you should subtract a value from the right side, because just to keep it equal. Okay, so that's what this was about. Use the distributive property. Okay, so this one is not that. So it's just a simple distributive property. 9 times k is 9k, plus 9 times 5 is 45. Okay. Remember, distributive property multiplies the term outside here by every term inside, with the factor outside by every term inside, the k and the 5. Okay. That's that. Why do I feel like things are getting easier? In Miss Peroni's class, 75% are boys. There are 18 boys in the class versus the total number of students. Okay. So it's a percent proportion. We want to know to find out the total. So this is going to be my, I don't know what that's going to be, but I know 75% are boys. And another way of saying 75 is 18, because, that's what 75 represent, 18 boys. So we want to find out the number of students in the class. Is the relationship, ugh, why did I pick these weird numbers? Divided by 5. A second, what if I divide this by 25? If I divide this by 25, I get 3. If I divide this by 25, I get 4. There it is. Now I can find my relationship. Times 6, times 6, and 4 times 6 is 24. So the total number of students in this class is 24, of which 18 are boys. Okay. Careful here with the next one. It says reflect point A as well as find the coordinates for every single one and the quadrants. So A is at 2, 7, quadrant 1. B is at -4 and 6, quadrant 2. C is, where's C? There is no C. No kidding, there's no C. So D is at -3 and -3, and is in quadrant 3. E is at 0 and 2 up, so it's on the y-axis. F, where's F? It's on 7 to the right, and how many down? -5 down, and that's in quadrant 4. So all that information is necessary. And we're asked to reflect point A over the x-axis. So here's my x-axis. So point A is going to go from here, somewhere in quadrant 4. So what's the distance here? 1, 2, 3, 4, 5, 6, 7. So we're going to go all the way down to 7. And that's my point A prime. So point A prime reflected is there, and its coordinate is going to be, so what's A? It's 2, 7. So this is going to change just a little bit. It's going to still be on the 2. It's going to be all the way down, -7. So there's a difference between A and A prime. Okay. Okay, so again, we did this with different numbers, so let's plot -88, 98. So on number line 0, let's just assume 0 somewhere over here. And if we were to plot -1, -2, -3, and we're going to go all the way to the left, and the first number we hit is -88. As we go along, -89, 90, 91, and -99 would be somewhere over here. So that's the location of my 2 points on a number line. So let's read which of these statements makes sense. So keys should plot -88 to the left of -98. So this guy Keith is saying -88 should be here, to the left of this guy here. Well, I'm not even going to read the rest because it shouldn't be on the left. It should be on the right, where it is right now. So this guy is out. Key should plot to the left again. Don't even bother reading. Shouldn't be on the left. -88 should be on the right. So we have 2 of them here that says to the right. So let's focus on those 2. Keys should plot -88 to the right of -98, right? -88 is to the right of this guy, right? It's to the right, so it's right. Because -98 is smaller than -88, and that's correct. And how do I know it's smaller? Because the number on the right is always bigger. -88 is bigger than -98, and 0 is bigger than both of them. Okay, so and the last one says plot to the right. Yes, plot to the right because -98 is greater than -88, and that's not true. So that's gone. Final answer, C. Told you in class when we did Spiral 7 that if you can change this to decimals, it makes life easier. Okay, so especially when you have fractions that allow you to do that. If you don't, like if it was 1/7 or 1/13 or one of those weird, okay, that gives you a non-terminating decimal, then I guess you would have to keep it as fractions. But this one, 12 1/4, I can write it as 12.25. 2 to the second power is 4. I can do that because it's not affecting anybody else, right? Not affecting any of my calculations. So I'm going to change that to 4. Times, in parentheses, 3 1/4 is 3.25 minus 1.5. So that's my problem. Just rewritten in a little easier way. Order of operation dictates that I should do the parentheses first. So I'm going to keep these guys here, just hanging out. And 4, I'm going to multiply by the difference of 3.25 minus 1.5. And if I subtract these two, I put a 0 over here. So that's a 5. I'm borrowing here. That becomes a 12. 12 minus 5 is 7. 2 minus 1. So that's going to be 1.75 inside the parentheses. I still can't add because I got to multiply now 4 times 1.75. So 1225 is still hanging out there. And I'll go 1.75 times 4. 1.75 times 2 is 350. And I'm going to times 2 again. So it's going to give me 7. So 4 times 1.75 is 7. Now I can finally add it to 1225. And that's going to give me 19.25. Okay? Ugh. So Sam buys 10 liters of milk. Each gallon costs $2.59. How much change will she get? She pays. So the price is quoted in gallons, and we have it the milk in liters. So I have to change the liters to gallons. So 1 gallon is 3. You know what? I'm gonna have to check just to be precise. I'm gonna pause this for a second. So let me see what I have here. So so let's change the liters because it's in liters, right? We have to find what's 10 liters in gallons. So our relationship is that 1 gallon is going to be 3.785 liters. So that's our relationship here. So I know what put gallons on top, liters at the bottom, and let's set up a proportion. So 1 gallon, that's what I want to find out. 3.785. So I'm going to put 10 over here. Okay. Am I doing this right? 1 gallon is 3.75. So if I have this, how many? So what's our relationship here? Well, side to side, definitely very hard, right? Nothing times 3.785 precisely what gives you 10. So look up and down, because we're going that way anyway. We're going that direction. So how does this 3.785 become 1? Divide by 3.785. And divide 10 by divided by 3.785. And you will have a calculator, hopefully now, as you're working this. So if you take 10 and you divide it by 3.785, that's going to give you 2.64 rounded to the nearest hundredth, 2.64 gallons. And that's how much 10 liters equals. Okay, so now it's much easier. So now that you know how many gallons you have, you can multiply that by the price here. Each gallon is $2.59, and if you have 2.64 gallons, how much would it be? So 2.59 times 2.64, it's going to give you, and again, rounded money-wise, so the actual answer becomes 6.8376. We're going with money, so we're going to round this to nearest hundreds, $6.84. I'm still not done with the problem. That's how much I'm going to pay for my milk, but I'm going to give the cashier a $20 bill. So if I give the cashier $20 and I'm going to be charged $6.84, how much change will I expect? I'm going to expect $13.16. So that's my final answer here. Okay. Tim had blah blah blah. So 3 2 meters. So we gotta be careful here. So he had board. So 1 board, 2 boards, 3 boards. Okay, and this measures 2 meters. This measures 2 meters, and this measures 2 meters for a total of 6 meters. I want to cut them into 15 inches long. So I want to make cuts here. So cut them into 15 inches. Okay, cut them. How many of these little small boards will I have after I cut all these into 15 inches? Well, I don't know, because this is in meters and I want to cut them in 15-inch parts. So I'm going to have to change my board, my total of 6 meters, to something that I can work with inches. So on your sheet, you probably have a relationship between centimeters and inches, which you don't have. Okay, what you don't have is meters to inches. So what we can do is change the 6 meters to centimeters first. So 1 meter is 100 centimeters. Okay, so meters here on the top, centimeters at the bottom. If I had 6 meters, how many centimeters would it be? Well, that's easy, 600 centimeters. Okay, so now instead of six meters in total, I can say that my boards are lengthwise, they measure 600 centimeters. It's the same thing. Now I can use the relationship, on the conversion sheet where it says 1 inch is 2.54 centimeters, right? And I can change, what do I have here? Let me write centimeters. I have 600 centimeters. So how much is 600 centimeters into inches? That's what I need to find. Well, side to side is not going to work, so let's divide. 2.54 to become 1 is divide by 2.54. So I'm going to take 600 and divide it by 2.54. 600 divided by 2.54. That's going to give us 237. And again, round it to nearest hundredths, 237.01, because the calculator says the actual answer is 237.007874. So, but we are going up to the hundredths place, and that 7 is going to make that go 1. So, in inches, 6 meters became 600 centimeters, and 600 centimeters became 237.01 inches. Okay. Good. Now that I know my value in inches, what the boards measure in inches, I can cut it up into 15-inch parts, 237.01. So this is all 237. So if I want to take 237.01 and divide into 15-inch segments, how many of those 15-inch segments can I have? And 237.01 divided by 15 is, I can have 15, oops, and I have a decimal answer, so I can have 15.8. So definitely 15 mini boards for sure. Can I make a 16th board? Almost, but I can make 15 for sure. Okay, quite a lot of work for this problem. Find the distance between 10 and -8 and 10 and 14. Okay, so anytime I have a problem like that and I don't have a graph, I make one. So, and it doesn't have to be precise, but it just helps me, visualize where my points are. So 10 and 8 would be 10 to the right and 8 down. So about here. 10 and 14 would be 10 to the right again, and this time we're not going down, we're going up. So this is 10, 14. So now I have a visual of my points and how far they can be, and I can sort of find out. But it's asking us to find the absolute value. So I'm going to write 10, 14, or 10, -8, which is I started with, right? 10, 14. And these two values are the same, so I'm going to take the absolute value of the other two. So absolute value of -8. And I'm going to, because they're in different quadrants, I'm going to add plus the absolute value of 14. Absolute value of -8 is 8. Absolute value of 14, right? Because we're finding distance from, sorry, not there. We're finding the distance that, okay, so this distance is 8 units. And 14 would be the distance from the x-axis to here, right? So to find the total distance, as you can see in the picture, you just add 8 plus 14 equals 22 units. Okay. Is that it? No. Find the prime factorization of 640. Yucks. Right, I'm going to do it on this side because I probably need room. Prime factorization, 640. I can do 64 times 10. 2 and 5. Circle, circle, because they're both prime. 8 and 8. 2 and 4. 2 and 2. So circle, circle, circle. And 8 is going to be the same. 2 and 4 again. 2 and 2. Circle, circle, circle. So the prime factorization of 640 using the product of only prime numbers is how many 2's? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7 times 5. 1, 2, 3, 4, 5, 6, 7. There should be 7 numbers. No. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Or written with exponents, 2 to the 7th times 5. So I expect this answer. The 5 Canadians, 11 Koreans, 8 Brazilians at a coffee shop. Jeez. Express the number of Brazilians compared to the total as a fraction, decimal, percent. Okay, so we want to know the number of Brazilians. Well, there are 8 Brazilians out of what? As a fraction, how many people are here? 5 plus 11 is 16. 16 plus 8 is 24. So that's what my fraction looks like. We want to change this to a decimal. So one way you can change this to a decimal is, let's see, find its equivalent as something over 100 if you want to go to percent first. But 24, 8, 24, 1 by 8, nothing's going to work. So I'm going to do the long way, which is just divide. Change something to a decimal, a fraction to a decimal, divide 8 divided by 24. Nope. Add a 0. 3 times 4, yeah. 3 times 4 is 12, goes 1, 72, that works. And then it's going to be 8 left over. I'm going to add another 0. It's going to be 3 again. Go 72. And going to be 8 again. So I'm going to go 1 more this time. It's going to be 3 again. So the answer to this, it's going to be 33, and to be more precise, percent. Sorry, decimal. Oh my God, what am I doing? So as a decimal, it's going to be 0.33. Let's go to the thousands, okay, because it's not. And then this to percent, 33.3%. Okay. Remember, I told you if you did cut it, if you did stop and made it 0.33, and you change this 33%, it's close, but 33.3 is a little bit more precise. It does make a little bit of a difference. Okay, would you rather have 33% or 33.3%? Or even better yet, if you went one more here, wouldn't 33.33% even be better? Okay, so if you went this far, I'll take it. This is even better. Okay, but definitely not this one. Okay, and this is, I think, the end.